Hello and welcome. I'm Bill Wake. We're here working on the Elm interpreter. We've been working on expressions lately, and we're to the point where we decided we should treat operators as if they were function calls because we have prefix operators that actually are function calls. Let's make use of those and improve our design a little tiny bit. Okay, don't know what that beep was. Oh, test's finished, I hope. Yeah. All right, so we have all tests green, so that's great. Let's see. So let's walk through what we're looking at here. So it's a multi-stage refactoring that we're doing, and so we're working on it piece by piece. One thing we've done is there were token operators, like a separate token for plus and minus and times and all the operators, and we're changing that over to use just one token operator, and it's going to pass the actual operator string as its argument. And we've modified everything to use that new form, but we've got some simplifications we can do and some dead code we can take care of. Once we do that, we're at the point where when we go to look up what function should this operator be calling, then we can just take the string that the operator is, like a plus sign, put parentheses around it, and that's the name of the function. It's a weird function name, but it's the way Elm works. All right, and then the operator stuff. Today we have an operator class, and we pass in the token, and then a left-hand side, right-hand side. So 3 plus 4, a plus for the token, and then 3 and 4 for the left and right-hand sides. Inside there, they have mappings from all the operators. So here's our new ones in use: op plus, op minus, and so on. Each one of those gets mapped to a primitive function that, like the first one, convert function numeric types, handles integer and floating point addition. And we have some for Booleans, convert equality, integer, floating point, and custom values. All right, and let's see. So we're going to get rid of this class because somewhere else, let's see, is there a prefix? Well, let's go to the parser. We can find it from there. So in the parser, we'll look for prefix operators. All right. A prefix operator returns a variable with that. And then we have a predefined set of functions. Let's see. Where did we put those? They're not an interpreter, are they? Oh, maybe primitive functions. Yeah. Okay. So here are all the prefix operators. And they've got curry of convert function numeric types. Well, convert function numeric types was exactly the same code we saw in the operator object. It just didn't have the curry on front. Curry is because curry takes a 2-argument function and turns it into a 1-argument function that, when passed the second argument, produces the final value. So the prefix operators are a touch more complicated than the simple ones, but I think it's going to simplify the overall system, and we'll only have this knowledge once, and that's what we want. We want to avoid the duplication. All right, so we will dive in. Let's go back to our to-do. Okay, so remove usage of old token operators from tokens. So let's look at our lexer. That's right here. Okay. Now we have equals. I guess we should figure out which ones map to op. All right. Well, here we go. Plus, minus, times, divide, and int divide. So plus, wherever you got off to. Plus. Okay. So let's just remove this and see who complains. Now we got rid of most of these and hopefully all of them. There may be some tests that used it for a sample or something like that though. No, perfectly fine. Okay, good. Plus, and then we got minus, there's star, and percent, and up arrow. I believe that was on our list. And minus. Float, divide, int, divide. Okay, so we're taking a bigger leap. Mostly because we can just call .op and substitute it in if somebody is actually using it. Okay. And I think double equals, where was that list? I believe double equals and equals. No, equals we keep, double equals and not equal. I'll just comment those just to be a little safer. Okay. Not equal. So you can see we are really simplifying. That's a good thing. Plus, minus, times, slash, 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 percent, up arrow, equals, not equals. Then we got our 4 relational operators and ampersand, ampersand, and bar, bar. Well, there's bar, bar. There's ampersand, ampersand. Greater than or equal. Less than, and less than or equal. Now, some of these others are operator-like, and maybe they will be operators. Plus plus is an example, but we don't support appendables yet, so we don't have any. We don't have an array class or anything like that. Okay. Cool. Usage of old token operators. Today's the 15th. And we're really handling infix operators. And what we did, remove usage of old tokens. Yes. Okay, we'll commit this. I'll say operator tokens. That'll remind us a tiny bit. Okay. Oh, well, I guess that's that. We finished that last time. Infix operators. Yeah, okay, we just didn't delete it up there. Good. All right, is operator. Let's find that. It's in Lexer. And let's see who calls it. Well, caller. Okay. Really, it's only used in one place, operator expression, and that's what's accumulating 4 plus 3 plus 2 times 5. It's looking for those operators. All right, and we can simplify that. Well, I don't mind the token knowing that it's an operator. That's fine, but we don't need to go look it up in a set. Now everything's an op, and only those things are ops. So I don't know. I think we can say if. No, that's not really helpful. Yeah. So what I'm trying to say is if the current token, how do I do this? There's definitely a way. Let's look it up. So we want to check if enum matches regardless of value. I don't know how to say it. Enums with associated value, that's us, name of string. Supports equatable. Well, we can switch on it. Yeah, there's a way to say if let too. Oh, maybe it's if case let. It's abbreviated. If case let puppy doing wait. Equals self in our case. If case token.op, and I don't need the let, equals self, right? Okay. I don't think I got a better way to say this, but if basically I'm saying if the current token self is an operator, and I don't care what kind, I just care that it's any kind of operator, I'm going to return true. And otherwise I'm going to return false. As always, if you know a better way, speak up, because I definitely can learn on these things. Expected member name following dot. Let's build this and see what's what. Okay, builds. I'd like to say, you know, if question mark, if token.op, I don't know. Something. It'd be nice if I could say it in a simple ternary, like return token.op equals self. But I don't know. I'll try it. Can I say return case token.op equals self? Is that legal? No. Case label can only appear inside a switch statement. That's a lie. We have one right here in an if, and we have another one in the enum itself. But okay. That's still an improvement. All right. So we used to have to take the time to look it up in a set. Now we just say, what's your type? Oh, you're a token.op. You're certainly an operator. All right. Let's see. So we did that. Okay. Change to use prefix operator function call instead of operator class. Yeah. All right. Let's see. I'm going to change this story down here is function calls, because that kind of applies to all that stuff. But change to use prefix operator function call. Okay, we did this as a sort of as a spike. And what we found was it's in post order. Yeah, so we did something like this. We just hard coded it to plus. We were just trying to find out if it would work this way. But instead of calling operator, creating a new tree node of operator type, we will push an expression that's a function call with the operator as a variable, and then the left-hand side, right-hand side as you'd expect. All right, and is this... Well, I don't know if we can say it's a refactoring. The expression is operator token. Operator token is a little bit of a weird case. It's an expression that's only used in the calculation of making expressions parse through this precedence parser. So that is basically a wrapper that takes whatever the operator is, and that token, it's a way to put that token on a stack of expressions, basically. Here is the op. All right, now if this is a refactoring, I would like to think this we'll have to do something a little more fancy on this, because we can't just take the plus. We need to take the actual op dot well, I don't know what we can do. Let's pause. Okay, this works. This has issues. Okay, we did that before in our spike. All right, so this operator token, let's go look at that thing. Well, how do we handle... We really need to get value out. Operator token. Well, what I'm thinking is if as string just gave us the value, then we'd be pretty happy. Okay, so let's make it so that if it is a token, it returns that. So we're gonna do the same thing we did before. Case let, if case token dot op. This time we want the let value equals op, the operator token. We're going to return value, and if it's an unknown, kind of not an operator token, we'll just return what we did before. All right, this may change this. Somebody may have been looking for that operator token word. I don't really think it's going to happen that way. Okay, but that lets us get at it. We were in... Where were we before? Oh, post order. Yeah. Okay, so now I think we can do this. We could say we got op. In parentheses, we're going to put the value of op dot as string. Oh, well, that's even not... What if I just did expression.asString? I think that's actually better. And now we don't need op at all. Okay, so because we wrapped it in an expression, it's got an asString. AsString now looks at the token, sees it's an operator, returns the value. And let's just see if this works. I think there's going to be a test or two looking for operator that we will change. Yeah, I saw something blip by. But not... Okay. For arithmetic op yields operator expression. Well, no, that's not true. It should yield a function call. Okay. And the expected then is function call. I don't know, I'm working a little backwards. With a variable. This is a variable of parenthesis slash $0. Okay. So expected is an array. Wait, how does function call work? Function call takes an array of things. Missing argument for parameter 1. Oops. Gotta use right bracket. Still something. Comma separator. No, there's something wrong here. Let me revert this. Whoops. Okay. We will. Whoops. Let's comment and duplicate instead of messing with it in mid-flight. Okay, so what we're expecting is a function call with a bunch of stuff. Okay, what's the problem with that? $0 is a token, but it's got to be a variable. Maybe I was missing a parent. All right, and then we really want the prefix operator, so we put another parenthesis in. Okay, let's just take this test, make sure we're making good progress here. No. Function call variable minus variable x, variable y is not equal to function call variable op minus. We're still getting an op in there. Sorry, where was that? That asString was operator token, right? His value equals op. Token.op let value. Let's see this thing. Oh, I'm doing it wrong. Oh. The op is coming not from the expression. The called code is correct. The test is wrong. Okay. We'll just print value. Oh, we see it there. It's plus. Yeah, so that thing's okay. It's the value of op. $0 is an op of plus. We want to get his value out. Ugh. Well, I guess the way we know how to do it, it's if let. There should be an easier way, though. Can I do that? Hey, life's lesson. Teach how to look up Google. Get associated value from enum in Swift. Swift 2, right? There's better ways. Cannot have a raw value. Okay, there's an example with some arguments. No. They're doing a switch. And that may be the easiest way. I mean, our if case is fine too, but yeah, if let's. Okay, I guess we're we're doing. Well, we're doing what they got. Okay, so we say if case. Token.op of let operator string equals $0. Then we can use it in here. Yeah, let's just pull these 3 lines in. And I'm going to put a fail in there just to make everything theoretically can't happen. All right. Makes this a little more complicated. Immutable value operator string. Let's use that in here. Operator string. Okay. So we'll peel out the operator string from the token. We will look for it here, and we expect this to work. That should pass green. Of course, I thought that last time. Oh, I'll just skip over that. Did this one work? No. Ugh. Variable minus is not equal to function call. Variable minus. I wish I knew which was which. I guess the first one is variable parenthesis minus parenthesis. Yes. Variable x, variable y is not equal to variable 2 parentheses. Well, something's funny. They both look wrong to me. This one has 2 I mean, the first parenthesis is coming from there. Parenthesis slash operator string parenthesis. Well, I guess we'll stop here and look, but expected parenthesis. Okay, variable always puts a variable parenthesis in front in its thing here. So that is provided by variable, and then parenthesis minus parenthesis, that's what we want. We seem to be getting somewhere. Well, why isn't there an extra parenthesis here? That's my question. When variable printed out. All right, but we'll run it and make sure. You know, I guess you have to see the comedy in it at some point. You know how many times you can say, oh, I expect this. And there it is. Okay, so let's look at expected. Well, I think we can say print expected.asString. Okay, so that's expected. The tree we got, I guess that's in post order. We wrapped that up. Variable. Oh. Why? Look at that. It ignores. Oh, I need one more. The black one, the last black one matches the outside S string has its call. Okay. And now for the third time where I claim that this should just work. Yeah, just like that. Okay. Clean this out. And I just want to visually separate things, make this readable. Maybe do that. Okay. So arithmetic operator yields an operator expression. We said that should be a function call expression. And that looks good. Relational op yields a function call expression. Well, this is, It's duplicated, so that's why I'm getting nervous. So this much, you give me a list of operators. I look for XY. It's okay. Yeah, it's making an input to our post order, and then evaluating it. So if we extract a method, I'll call it check operators as function call. Okay. Now, I think I should be able to do that in each of these cases then. As operators. And that should replace this. And same thing here. That. All right, let's just see if that does the job. Well, I guess that got through the post order test, but there's still some holdouts. Okay, let's consolidate this. I'm going to move this down. Take out these lines. Okay. Yields function call expression. This should be yields function call expression. Okay. I believe those post orders should be okay now. And these others, 1, 2, 3, 4, 5. Okay. Expressions with operators. Okay, yeah, so now we're getting back function calls. All right, so this is basically testing that the main parser calls the operator precedence parser and produces what it produces. And we're changing that. So now it's a function call with a list of stuff. Well, I'm trying to figure out where that bracket goes to make this balance. That, okay. It's got to be, this should be a variable parenthesized plus and value 3, and then 4 times 5 should also be a function call with a variable of parenthesized star. This is all in a list. I guess I don't mind doing it like that. And same thing here. Like that. Okay. That seems right. Okay, same deal here. We're transforming what we expect to a function call list. First argument is a variable. And the second argument is another function call. First argument is a variable. Yep. Tuples. Okay, same deal. This should be a function call with that. And I don't know if I don't think I'm over testing it with this. And we are having to change a number of assumptions because of it, but I think that's all right. And this isn't exactly TDD. It's kind of backwards, right? We're taking the answer we want and seeing the consequences. But we know we've changed operators, so we have no choice on this. Two, 3, and brackets. All right, let's see if everybody's might be missing one yet. I don't know, I think we did 5. All right. Okay, so I think with that, our post order, we don't need these 2 lines, we just need this. And maybe formatting would make it a little more readable. I hope. Okay. Should be no effect. Okay, so what we did was we make the parser return function calls for all operators rather than use a separate operator expression. And I guess that's true here. All right. I think we're probably due for a break, so let's take a couple minutes and we'll come back. We'll delete this operator class and then figure out what's up from there. So see you in a couple minutes. Hey, welcome back. All right, so now's the payoff for this operator thing. We got rid of an intermediate node type. So let's go see who uses operator. Operator token we have to keep, remember, but operator itself, let's see where we can find this. I guess callers here? No. Can I do that on the initializer? Operator tests. Well, we don't care about operator tests. I think let's take out operator tests. We'll just comment out the whole thing. Whoops. Over here, that, run our tests. So yeah, they pass, but now I think there are no callers on operator itself now. That'd be nice. One precedence parser test. Treats operator as a lowercase name. Precedence to token. I don't know what that means. Well, we have this expression to token thing. Let's take a look at that. I don't think that should be testing operator. I think it should be testing operator token. It just takes the operator itself. Oh, no, that's not correct. Okay. Yeah, I know what's going on now. It was basically it was trying to take the result of an operator. So if you said 3 plus 4 plus 5, the 3 plus 4 is supposed to be a computed value that is precedence-wise just the same as any other value. And so basically we changed operator token to function call. Well, we did this. Variable plus, well, let me pull back my other value I deleted. All right, so this was operator, now it's function call of variable that oh well, let's put the parentheses. Variable and value. 2 arguments to a function call. Token lowercase name. Okay, yeah, that should be it. Because we did transform operator to function call, so we should reflect that here. Yeah. And that is correct from the precedence point of view, making sure that calculated values act like it. Okay. But the good news is this is not there, so we can delete it. Delete to trash, and that was operator tests, and here's operator. One more check. Nice. All right. So we deleted the operator class. Yay. Took a while, day and a half, or well, couple good hours anyway. All right. So that's that. We'll commit this. Delete unused operator class, and that's a refactoring. Okay, let's run it, make sure the expressions all still function. But I think we did good. 3 plus 4 times 5 should be 23. All right, 3 plus 4 times 5 should be 23. 35, yeah, 7 times 5. If you do plus... You can do plus 3 with 4 should be 7. This is using the prefix function. If you just do plus, well, times 2, you should get a function back. All right. We're not dealing with the types quite correctly yet. Basically, when it gets confusing, we punt. But our data values all know their own type, so it's somewhat typed still. Okay, but those look fine. And okay, I guess we could do 2 to the 3 to the 4, 3 to the 4th. This is too big, right? I think that's going to blow up our number type. Yeah. Okay, we'll come back to that challenge. Well, let's take a small one too. Oh, we blew up. Okay, that's okay. We're gonna shift gears anyway. But I'll add something in here just to kind of story arithmetic, and the issue is crashes interpreter if numbers out of bounds, e.g. too big, divide by 0, etc. All right. Now, where we're having an issue, okay, this part we did. Plus 3, 4 turns into a function call with plus, prefix plus, and 4. And now 3 plus 4 also turns into a function call with plus 3, 4. So that's the stuff we did. That's done. The deal, though, is what we tried to do, what we set out to do yesterday was say, okay, now we have arithmetic. We should be able to write a recursive function, right? And let's do that again and see what's going on. Crazy. Okay, we know part of the issue. So I should be able to say function of x is if x is 0, then 42, else function of x minus 1. Okay, and that should be a valid function definition. We didn't have support for equals equals, so we had to go back and add that. Then we said, oh, let's fix up all this operator stuff, and I don't know, it's not clear to me that our function parser is able to deal with all the complexity we have either. So I don't know if he can handle arithmetic expressions. Let's see what this does. This should be okay. It's A goes to error is a little suspicious, right? It means something went wrong probably. But if I say function of 0, it should come back with 42, and I don't think it will. Okay. Expression line 1, column 13. I think it's propagating. That's the error we got before, so we probably should have pulled that out. But 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Missing then or else. Yeah. I think we've introduced this notion of operator expressions that have calculations, and we don't have them used consistently throughout. All right, let's try this same function over here, though, in the Elm REPL, the real one. Okay, so we can say function of x equals if x is 0, then 42, else function of x minus 1. All right, so if you pass 0, you get 42. If you pass 1, you get function of 1 minus 1 is function of 0. You come back recursively, you get 42. You get 42. All right. So now we have number goes to number 1. A little interesting. So x could be any kind of number, and then 42 is a number, but not necessarily the same as x. So x could be floating point, and floating point could return number for an integer still. All right, but if we call a function of 2, it should work. Okay, and actually function of 3 is 42, but function of minus 1, I don't know, can we say minus 1? It blows up. Okay, because negative 1, it says, oh, call function of negative 1 minus 1. Well, that's minus 2, and it just keeps deeper and deeper in the hole. Can I cancel? Good. All right. So something's going wrong, and what our complaint is, here's line 1. It'd be nice if I print the line numbers out, wouldn't it? But line 1, column 13, it's basically the equals equals. It's getting confused there, and that's on the if expression. I don't know if the function definition is also ready to deal with it. All right, so let's go see what we got. And this still doesn't answer, can we call a function recursively? And I don't know the answer yet. I know we're supposed to be able to. All right. Let's close everything else and go back to, I guess, parse. Well, yeah, we can. We're still running, right? So I'm going to simplify. Instead of function of x, I'm just going to say if x equals 0, then 42, else 21, 27. Okay. X doesn't have a value yet. Values are not comparable. Okay. How about x? X equals 1. Now try again. If x equals 0, then 42, else 27. Values are not comparable. Let's find that text. All right. And this. Primitive functions. Convert equality operator. Oh, interesting. So x, what type did that get? X's type was number. And 0 should be number. So I would have thought they're number, they're not integer value. Well, I guess I thought they would still be integer values, but if not, they would be a double. Well, I'm not sure where to jump in. I guess we're after anything that's going wrong at this point, and this may be a reflection of we're being loose with types and paying the price. But I'm going to break here, and I should be able to say 3 equals 4. That should be a Boolean false. Okay, now let's make num1 equal 1. Num2 equals 2. Num1 equals num2. That's a false. Num1 equals num1. True. Yeah. Okay, so it looks like our equal operator is doing its thing. I'm not so confident about our if. If num1 equals num2, then 2 else 1. They're not equal, so we expect to get 1. Not comparable. Did I break? Why? What's this? That's the assignment. That's the only use. Let's stop here. Convert equality operator. This should be the one used for equals equals. Okay. Num1 equals num2. I don't know why we didn't hit it before. It may be that because we're producing a function, this brace here says we're producing a function and the function is not being evaluated until this moment. Okay, but x and y are integer values. Let's step over. All right. Print x, print y, value 1, value 2. And I think we can continue. All right, so that thing is fine. All right, what if we just said if 3, then 2 else 1? I think that should complain, and maybe it's getting the values not comparable. Nope. Okay, if num1 equals num2, then 3 else 4. All right, we're here again. Okay. Let's step over. All right, so let's look at num1. X. Missing then or else. Okay, so the deal is our parser didn't parse it. Now, there's... Right, and so it didn't parse the expression. It has an error expression, so that fails to be a float. It fails to be a custom value. It must be an incompatible value. That's a little misleading then. Line 1, column 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. The equals. Yeah. All right. I think I know what's going on. We want to get to the parser. And the real thing going on here is we have operator expression, which is expression plus, which are the function calls, followed by operators and more expressions. And we... Sorry, I'm getting confused because this should be expressions plus. All right. So we have this operator expression. In the old days, at some point, we just called expression, which gets us some sort of expression like this. Then we said, oh, wait, you got to do function calls. And that's one or more expressions. And then, oh, wait, you got to actually do operators. And then we get our precedence parser involved to take the result of all that and make sense out of it. So I know we have places that still use expression or expressions, and that's not quite correct. So, okay, so here's function definition equals expression. Let's see, partial result. We get the equals. If it's a function call, we dig out the expressions from it. Otherwise, we create a partial result. And then here we go. It's the RHS equals expression. So partial result is the stuff before the equal sign. And we're trying to make sure it's either a function call or it's a list of variables. We're checking that. It should only have variables there. Then once we know we're okay on the left-hand side, we call expression, but we should be calling operator expression, because you can say function of x equals x plus 2, and let's run that and confirm that fails. So we're getting down to simple cases that really do fail. Okay, this definition should be fine. I think it's really just defining it to be x. Okay, and let's call function of 3 should be 5. It's only 3. It omitted this, and somewhere there's an error that's not getting caught. Okay, and really, well, I don't know. That's a little confusing. LHS, drop first, reverse the list. Okay, this is matching the functions and calling them, and then defining the result. Ugh. Right. But I don't think that's the if case, the if statement, or if operator, I guess you'd say. Let's find reserved if. Okay, here's if statement. All right, so we have the word if. We skip over that. Then you say if there's a condition, then do this, else that. Okay, but notice the expression is only going to accept function calls. It's not going to accept operators. All right, so I think basically we have a case where this should be calling operator expression, and it's not. Okay, so we need a test. Bottom line, and it's a parser test. And if I'm lucky, I said check if. No. Let's look for if. Here, okay. Test if. So we got very simple if statements, right? But if this was if true, then 3, else 2.5 times 2, it would not produce the right thing. Okay. So that's mostly getting at types. Let's take this one. With infix operators. Okay. Else 2 times 5. All right, now we know this is no longer integer value 2. It's function call with a list of stuff. Well, one of which is integer value 2. Another is integer value 5. And the first thing is a variable, and it's times that. Okay. So an if with infix operators, we expect to get an expression back. And I think what we're going to get is just if true, then 3 else 2. All right, let's see how this looks. It's saying we're getting what we expected. I don't see how. Okay, let's evaluate it. Okay, of all the guesses I made about what that would be, that was not one of them. If true, then 3, else 15, else 10. And we get 15 out of that. Custom value true, integer 3, function call times, integer 2, integer 5. That's really weird. Like, I don't know. Oh, 15. Well, 3 times 5 is 15. It's almost like it skipped over the integer 2, but it says it's got it there. So let's look at, sorry, let me run this one more time. Okay. If true 3 function call variable star 25 is not equal to function call variable star if true 3 5. Okay. So I think it's doing if true then 3 else 2 as one expression, and then times 5, the whole thing times 5. So yeah, function variable star if true 3 2 5. So it's like the precedence of the if is higher than the times, which may be true actually. If true, then 3 else 2 times 5. And that actually might be 15. No, it's 3. Can I do this? That should be 15. Okay, so the deal is we're parsing it like this one instead of that one, and that one's the one that should be done. Okay, so the fact that this is wrong, that gives us enough excuse to call operator expression. Oh, we're going to find the if statement again down here. All right, let me run one more variation over here. If true, then 3 times 2, else 5. 6. Okay, so we do want the operator to be lower precedence, higher precedence. All right. Parenthesized. If statement. Okay. The left should be, and we had it up here, in tuple operator expression. That suggests to me that I would have been better off making operator expression be expression and dealing with it inside, but that's not the way we did. Okay, so operator expression. And same thing here. All right. No. Okay. Who's failing? 2 things. If without else fails. Did it get some other missing then or else? Oh, the location changed. Yeah, that's probably okay because operator expressions let you have you can call function calls and it probably doesn't know the difference between them. I don't think I want to sweat that one. What about this one? If true 3 function call variable 2 5 must have a compatible type. Okay. Well, I would expect Elm-type.number. Integer value 3 should have a number type. I would think function call variable whatever should have should also have a number type. Okay. We're stacking things up again. If without else fails. That we dealt with. Okay. So the failure here makes me wonder if our function call, it may be that our function call is just returning the wrong type. Let's go in the parser and let's go in enforce if semantics. I think that's where it throws that. Okay, and we'll just run the one test. We may be getting an unknown or something like that, and that would definitely blow it up. All right, so we got a condition. Print condition. It's a Boolean value true. Yes, that's fine. The left integer value and the right number. Function call type equals unknown. Generic. Yeah. Okay, so this is it's a bigger step than I want to take. Because what we're seeing is the function call has type unknown, meaning you're comparing an unknown to an int, and you're saying they're not compatible. Result type is error. Whereas enforce ifs, okay, joint type. Let's look at our operators. They were in primitive functions. So I don't know if we primitive. I mean, we kind of let it go expression to expression. Let's see what convert. Let's take the simple one here. Well, his type is convert function integer. Okay, if x and y are both integers, then we're going to calculate the integer value. All right. I mean, that seems okay. Maybe we're just not bubbling the types up enough. I mean, we know int function is, I mean, it's like divide. So it takes two ints and produces an int. So this is the Swift level divide. And we're going to take the x value and y value, which are the two integer values, and then their Swift values. So it's back down to a Swift integer. Okay, and then we call int function. I guess the question is, what type does curry have? I mean, integer value says int type. Excuse me. Sorry, excuse me. The integer value gives it a default type. We can go see that. If you don't specify, it comes back as a number, which is default for them. So this thing is a number or an error expression, but you don't know which. Yeah, I'm just puzzled here. Like, prefix operator primitives, do we know the type of this thing? He just says primitive. Expression Elm type unknown. Okay, I think that's right there is the thing causing the problem. It just assumes everything is unknown to unknown, and we're going to have to pass something in to tell it, no, this is int to int or whatever it is. Okay. All right, well, it's time for another break, so we're in a failing test. Come back for the thrilling conclusion. but somehow we're going to have to figure out these types, and the function is going to have to reflect the primitive type. And maybe we can do it. We got the operation is expression to expression. So it should be like int to function of int returning int, or number. Okay, 2 minutes. See ya. All right, welcome back. Okay, so this is an interesting challenge. So we got this operation, expression goes to expression. Where's that coming from? Well, maybe first step. Should we just get rid of this stuff? I think we're going to do that. I'm going to revert. I think the change was okay. I think the test was okay, but well, maybe I can get by with commenting this. We're not ready to do this test. All right. And hopefully tests pass. Oh, we've got to change that 17 back to a 16 probably. An error. Okay. Revert stab at using operator precedence in the if statement. Okay. Now let's focus on primitive and primitive functions. The type of primitive. So it knows enough. Okay, it knows it's getting a function from expression to expression. That's the operation. I'm sorry, there's a little noise in the background there. It knows it's getting expression. The result is expression goes to expression. So the primitive type, it really should take the type of X and the type of this. The type of the whole thing is, well, in our case, it's number goes to number. Or let's take equals equals. We're comparing a number to a number and getting a Boolean back. So the type should be number goes to a function return, of number going to Boolean. Okay, so the primitive function that we really should be passing in the type of X and the type of Y. Now, do we know them? Well, Curry gets this. Convert to failure returns an expression. Expression goes to expression. I think people are going to have to start being specific about types. And all right. So I think the function defaulting to let's see, in primitive, this thing defaulting to unknown, that was me being lazy. I was gonna say us, but I'll put it on me, the guy doing the thinking and deciding and typing. So we had said, okay, we just aren't going to worry about types yet. We'll just call it unknown and hope everybody is okay. But there are things that check types and they get upset when they get unknowns. So that seems good. But the type here, I think the operation is not enough information for us. I think we need to know the type of the operation we're getting. And that type should be function of something to something. So let's do that. And I'm going to make a refactoring out of this. I'm going to say you should tell me the type. And let's say the type of Elm type. Okay. Yeah, I can just say type of Elm type. Okay. And it should be something that we're going to initialize with. Now all the callers, we need to go fix them because they're not passing in the type. Well, we know there's at least one here. Primitive should take a second argument. And for now, we're hard coding it to this. And then here's another primitive that should take a second argument. And it's hard coding it to that. Isn't that lovely? Okay, primitive of this. Trying to get the parentheses matching up in a way that makes sense. Ugh. First argument is that. The second argument is that. And then the argument of this is that. Okay, and I'll put this paren down here just to make sense of it. Okay, so anybody who calls primitive, if we want to be equivalent to what we are, we push this argument out. And if we had better refactoring tools, it would do it for us. We could say introduce parameter and have it push it out for us. But let's see if anybody else is calling primitive. I assume there's some tests that are going to break. Not compile. Okay, nobody's tested that directly. That's kind of interesting and a touch unfortunate. I see primitive functions. I don't even see primitive at all. Okay. This is progress, so I'm going to claim it. Refactor push type argument of primitive out to its caller. And the benefit I'm seeing is I believe this makes primitive more correct. It's still some sort of functional kind of thing, but its type is now reflected in the type of things. Now, how this thing does its job and applies and whatever, I don't know. We'll have to see. But in terms of types, we're saying if you tell me the right type for the primitive, I will pass it along and use it. Yeah. All right. Now, primitive functions. We look at this and we go like, well, that can't be right. Function of xy. Well, these things are going to get more complicated is what's going to happen. This function is the outer one. Okay. How do we do this? Okay. So if curry is taking a function of 2 arguments and turning it into a function of 1 argument, each of these expressions should have a type. And now the inner one, function of x, y, the type is type of... Okay, wait a minute. It's got to be the type of the function, and I don't know that I know that. Oh boy, what are these things doing? They're giving us expressions. Well, expressions have types. Okay, so I believe the type of function of xy is, well, no, I should say the type of primitive of this thing is the second argument type and the return value type of the function. Well, the return value type of the function is expression goes to expression. So we should be able to figure that out. Primitive y. And the second one, it's a function from the first argument to the result. So it's a function from y. Well, I don't know. We're going to have to... All right, we're going to have to write some tests, but I'm not quite sure where I'm going. Okay, so let's take convert function. Let's take convert function integer. I think it's a simple one. Convert function integer. It takes a 2-argument function. Let's go there. This is why functional stuff can be crazy. It's all there, but my goodness, like setting up these primitives to be just right. And once you do that, everything else should just bubble out. And we're not bubbling out quite right. So we're going to pass in a Swift domain function, takes 2 ints, returns an int. Okay. And the function we return... Okay, the function we return takes 2 values, x, y, and if x is an integer and y is an integer, then it returns the computation. So I'm having trouble getting from... Okay, so this integer value is this. Okay, that's the overall expression, and it's the result of this int function being called with 2 arguments. So I'm creating a function that basically this function is a wrapper function that takes a Swift function of 2 arguments, like integer divide, and it produces an interpreter level function of 2 arguments. And then Mr. Curry comes along and he converts that into a function returning a function return, that kind of thing. He converts the function call into 2 function calls of 1 argument each. Now the integer value on the result of this, so I don't know, it's like we're getting... Maybe I need the type as well. You return a function of 2 arguments to 1 argument, I think maybe you should return me the type of this argument, of this function. And I don't know how I do that. Well, I could make a tuple out of this. You return me the value? No, it's the whole thing. This is the function we're returning. Okay. And we could even create a separate function called, integer divide or integer apply or something like that. And it would do its job, and we're returning that thing, that function. Okay. So if I'm returning a type as well, I think I'm returning a type I don't know how to express. Maybe I'm not. Maybe tuple covers it. But I don't know if we do tuples of types in our interpreter. But I'm thinking what I would like to get out. Oh boy. Can we pull this function out? Maybe this thing is returning different functions. Maybe that's what's going on. Because integer value, it's like if we have an integer value, we want this function type to be integer, number goes to number. And it would be nice to just get that function returned. But, oh gosh, I just get balled up in this very easily. All right. I'd like to know. I mean, this thing. That's a heck of a thing to return. But we're returning a function. You give it 2 expressions, it gives you a new expression. And we would like to know its type. Well, its type depends on which case you take. Let's go to a harder one. This one. This is the thing that knows if it's 2 integers, treat it as an integer. If it's an integer and a float, treat it as a float. And I don't know if I can be explicit. It's like you don't have the values x and y to make a decision because you're just returning the generic function. I think you get to watch me stew for 15 minutes, the next 15 minutes. Okay. X, Y. I've got to know what my values are before I know which function to call, and I don't know that till runtime. But I should be able to get the type. How's that going to work? If I don't know the value until runtime, I don't really know which version is getting called. So it's very hard for me to tell the type at this point. The type is sort of like, well, it's number goes to number for this one. Number cross number goes to number. And maybe handling the ones with 3 functions are maybe just too. We got this custom value one for equals or not equals. And again, you don't know until runtime. Like, what's the type of this overall function? I don't know. It depends on the types of the arguments. And you're not telling me the arguments until the function is called. So something's funny there. I mean, maybe I can't just go off the operators. I mean, that's a possibility. Maybe what I have to do, like, what if I had to look up the operator and the 2 types? And then I gave you a function for each of those. If you tell me the types of the arguments, I definitely can tell you what functions they are. And what makes it hard is we've got, 10 operators going at this point. But if we can get one of them right, I think we would be okay. And maybe it's the type. Maybe the operator maps to a map of types or something like that. And then we could tell the difference between the ones that want to convert ints and the ones that don't and all that stuff. Okay. All right. So somehow, if curry, got to go the other way this time. Curry has to have the information on the types of these arguments. If he doesn't, he has no way to do this thing, and yet it can be done. So we know there must be a way to get it up there. X and Y are not being evaluated until actual runtime. So we're going to have to know the types coming in. Oh man. All right, and I wish I knew if I could make it work the way I'm thinking about. Primitive looks a lot uglier when you have to be specific about this type, doesn't it? Function of xy right now is just returning the function itself. If you could return me the types, I would be happier. Although we're getting pretty ugly, but if it were number goes to number, okay, which is sort of this one. Let's see what this says. Oh, like, what is the type of the plus operator? Number goes to number goes to number. So it really does know. Let's do equals. A goes to bool. Okay, so now it knows to generalize. And maybe our types have to do that. Our function should declare Well, I definitely don't mind our function having to declare number goes to number goes to number. Or A goes to bool. Okay. So let me recap for the 8th time. All right. So when you call this function, you're passing in a function, it wraps some operator. Okay, so a function double says I only know how I do double, double goes to double. And all right, I do double, double goes to double. You need to know that. So you need the function, the unevaluated function, and you need its type. I don't think there's a way around that. And if you're doing that, like, you don't need... All right, so could we pass that as an argument to Curry? The inner type. It's a boring thing. Well, it's an unknowable thing. What if you pass me the three types? Argument 1, argument 2, result type. Let's suppose that's the case. Okay, so this becomes horribly complicated. But you gotta tell me the three types. You gotta give me LHS type of Elm type. You gotta give me the right-hand side type of Elm type. And you gotta give me the result type of Elm type. And I don't want to force everybody to do this for now. So if you gave me Elm type unknown and Elm type unknown, I'm gonna let you default them to unknown. Now this thing, the type of the inner one is the second argument. Right hand side type goes to the result type. Got a little too much type in there. Okay, function, y in fn of xy takes a y, which is the right-hand side of xy, and it returns the result type of the function. That seems true. Okay, unfortunately, the left-hand side, this one, LHS type, what does it go to? Well, it goes to this. That. The left-hand side gives you a function which, given the right-hand side, returns the result type. I think that is correct. This primitive y in this takes a right-hand side type, returns a result type. That function does. Then, so this type is function goes right to result. Then this function here takes a left-hand side type, and his type is the resulting type of this. Mtype.function. Yes. Okay. Now, I think so far that's a refactoring. It's a little bit disingenuous maybe, but nobody's doing anything except returning unknowns. Well, no, it is a little different. We are returning a function, but nobody was looking at that before because it was lying. It was just saying unknown type, meaning like we'll get back to it someday. Okay. So I think this is progress. If you were to tell me, let's take plus. If you were to tell me the three types, number, because number goes to number, is the type of an operator. We'd be plugging those in. Okay, and let's try that. Elm type dot number, Elm type dot number, Elm type dot number. Okay, I think this should just work as it worked. Okay, now, how can I tell, is it any better? Well, let's run it. Let's do some experiments, do the same thing we did on the other side. Okay, what is the type of prefix plus? We want function number goes to number goes to number. I don't know if, okay, I feel better. All right, function of number goes to number goes to number. Function of number goes to number goes to number. Okay, so at least in the structural sense, we've got something better. Okay, now how can we tell? I'm trying to figure out at which point we should put a test in, but I think we're going to stop here. And let's put some stuff in the to do. Okay, so allow operator expressions on the right hand side of define if etc. Okay, but what we're doing is make operators tell their actual type, not just undefined. Right, and that's what we're doing in primitive. Oh, sorry, in primitive function. We're currently defaulting to unknown, I should say. Okay. So we're defaulting to unknown, but if you tell me your type is numeric or number goes to number, I can curry it properly. Now, I don't think I can embed that. Yeah, I don't think I have a way I can embed that in the knowledge. Like when I get this thing back, there's no way, there's nothing there that can tell me that. Because I have a Swift function. This thing is a Swift function of type expression goes to expression. But yeah, okay. So we will pick up there next time, which is next Tuesday, 1 to 3 p.m. And I think we're going to have to figure out a way to tell this case from this case. And I'm not sure what's going to reveal it, but we need to figure out how do you know? I mean, the only difference I see is if we do minus, well, star would work. His type is unknown, unknown, unknown. Okay. So it's got the old types. Somebody looking at that, when somebody evaluates it, they would like to know they have numbers involved. All right. So, yeah, we'll pick up there next time, and 1 to 3 p.m. Eastern Daylight Time on Tuesday. And thanks for joining me today. And we will see you another time, I hope. Bye-bye.